In problem 3, the actual measurements were known. Often you don't know actual measurements, but you know how precise your measurements can be. Think about the last time you used a ruler. Because the precision of a ruler is limited, you measured to the nearest unit, or fraction of a unit, such as centimeters or quarter inches. The most any measurement can be off by is 1/2 of the unit used in measuring. And that makes sense because we either round up or round down to the closest unit. Problem 4, finding minimum and maximum dimensions. And this one's about posters. You're framing a poster and measure the length of the poster as 18.5 inches to the nearest 1/2 inch. 18.5 inches, and you're measuring to the nearest 1/2 inch. That seems important. What are the minimum and maximum possible lengths of the poster? All right, well, we know we were measuring to the nearest 1/2 inch, so the greatest possible error is 0.25 inches. Make sure you take a moment to understand that. Because if your measurement happens to be on the right-hand side of this particular quarter inch, then you would round up to this 1/2 inch. If it's on the left-hand side, you would round down to this 1/2 inch. So again, the greatest possible error is 0.25 inches. So we take the minimum length, or to calculate the minimum length, that's going to be the measured value, which we measured to be 18.5 inches, minus the possible error, so that's 18.5 minus 0.25, and that's 18.25. So the minimum length of this poster is 18.25 inches. The maximum length, well, once we found the minimum length, the maximum length goes pretty quickly. We're just going to add that same amount, 1/4 inch in this case, to 18.5 inches, so 18.75 inches. So the minimum possible length is 18.25 inches. The maximum is 18.75 inches. Your turn. A student's height is measured as 66 inches to the nearest inch. What are the student's minimum and maximum possible heights?